Hello, and welcome to a bit of a slow-paced stream on my part because I'm super tired. Um, yeah, I've been cleaning up some stuff, but in general, we uh, are pretty much in the same state as where I left off things during the last episode. Let me just see. I'm just gonna check some stuff here. Yeah, okay. Stuff. Um, everything's running. Okay. So, I kind of like left off things here where I'm just messing around with the stream settings anyway. Um, so I left out things with this cube snapping to whatever we're hovering over in terms of grid space. Right now it doesn't really care whether the grid is actually possible to build in, because right now we're just using this as a proof of concept. So yeah, let's keep on building on this what do you call it, build system or whatever. Right now we're handling mostly the rendering part. uh, um, we added the whole this is object creation. Okay. So yeah, we don't need this anymore. Compile game state flags and params and frame data and flags. Yeah. Let's do something like flags. And let's do computations. And we don't need this right now. Okay. And yeah, the last episode we did this whole thing where we changed the code to be yeah, based on whatever we yeah. So basically we computed our rays from our mouse, and we did a plane intersection test to get out the grid x and y, or rather this is actually world space. This is C, this is not Y. And yeah, we use the computed data to do an intersection test whenever we click, and we're not click on a window. So this is basically what you see here. I selected the grid here. We don't need this check right now. We might disable it. Yeah, maybe we should just disable it right now. This was more related to our chess game. Basically, we could have done the same thing here for our chess game. Let's see, during debug here. Let's disable this as well, because we don't need to do that. Okay, so we disabled the clicking stuff right now. And we could basically just test whether we were in the grid coordinates and do selections in terms of that, but yeah, we will make something that is more to our use case. Okay, so I've been contemplating whether to because we want a build panel right now where we can select different buildings and actually build stuff. We also need some build logic. Um, maybe call this build logic slash data containers. Now plus. Okay. And yeah, I've been contemplating, well, buildings are not kind of like simulation related, is it? I mean, I'm not sure. We really want a simulation is more like, at least from my perspective, is more like something that we do each frame to alter the game state depending on the input state of the game. So, for instance, update the game timer, actually compute it. So we could do some kind of like time-based simulation stuff. And we update the player movement animation stuff. I mean, maybe this would actually be related more to a sort of animation system. So maybe moving the actual player is fine to simulate during a simulate step, to update the player position, do yeah, unsure whether this should actually be inside a simulation step, but yeah, at least for now it's there. We have a collision detection, which is at least part of the simulation. Um, at, at least I think. Um, but a building system and its logic is more like it's altering the game state, potentially at least, but it's like a separate system which is more linked to, of course, the game state in terms of altering the underlying data of the actual game state, but it doesn't do a lot of changes to the game state. It only adds buildings or removes them or and disables different parts of, well, whatever is supposed to be yeah. Whatever is supposed to be um, be done during a simulation step. But other than that, I think it's an entirely different system. So maybe we should do a separate kind of like file or set of logic that kind of like um, what do you call it? Handles the for instance, just a separate system. Yeah, I think so. At least we can try it out. And we can merge it with the simulation step, but yeah, I think that makes more sense. So let's see, source here. We have our simulation, we have our overall application, we have our game types, we have an entry point, we have some system values that we do not really care about right now. For some reason, IntelliSense doesn't recognize this area here. Maybe it's because I do this immediately after. No. It does recognize this. Oh, sometimes IntelliSense is just so weird. Anyway, doesn't really matter. Let's just close that. We do not want the computations right now. Yeah. So let's add a build system. And I don't want to call it building, but let's just call it build system. Yeah. And we don't need this. And let's do a namespace, DXC, namespace, build system. Oh, well, maybe builder? I don't know. Okay. And we will do this SSC style thing again. So let's just do a void. Let's do a tick or maybe update or whatever. Yeah. Include game types. Let's do a game state data, game state, and definitely not const. I was about to type in const. Okay. And let's do a thing where we kind of like draw building stuff, handle player input. So it's basically like this. And what is our system values? We have system values here. Okay. System values. Right now we have our screen size in here. Just a sec. Mm. I'm sorry, excuse me. I'll be continuing in just a moment. I just need to do some stuff here. All right. Okay, so let's start by um, can't always. Yeah, so um, yeah, okay. So we want always, yeah. So basically, we want to set our. Okay, of course we need ImGUI as well. Is it called? It's just ImGUI. And we don't want it in the corner, but we kind of like want it at the bottom of our screen, the X is fine, but we kind of like want the height to be, is this an int or, yeah, it's float minus, well, maybe 25 pixels. And it's GUI, ImGUI, set next, window size. We can be explicit here. Let's see, can we do on the X, we do a width and then height here. And then we create the window here. Build tool. Let's do a background, no title bar, no move, no scroll bar, no collapse, no save settings, no focus on you, no input, no inputs. Well, I'm not sure whether that flag is actually no mouse inputs. Let's see, we don't mind, you know, we could also just do no title bar, no recess, no scroll bar, no collapse. Yeah, no nav and let's see, no nav. Okay, and I'm going to end here. Okay, doesn't render anything. Test. Still doesn't draw anything. Should be here at the bottom of the screen, right? Okay. Let's just do 500 here. Huh. No decoration, no title bar. Huh? What happens if I do something like this? I mean, we should. Oh, I know why. I'm an idiot. Okay, let's convert this back. But we don't need this. No. We of course need to include it. Build a system. There we go. We have a thing down here. ImGUI set next window style push style bar. Can I set no border, no child bar, no scroll bar? Let's see. Remove. Oops. Remove border. ImGUI. Okay. ImGUI. Get style. ImGUI. ImGUI style. Okay. ImGUI style. Style. Style dot border 0. Oh, wasn't that window border size? Oh, frame window border size 0. What? Let's do maybe like this. Oh, we ended up with no border. Maybe we can do... Okay. Also, if I do this before the window... Mm, does this... Okay. Let's see. Uh, um. Okay, let's just try doing this then. And then setting it back afterwards. Yeah, so this one now doesn't have a border. But if we don't do this, all styles end up borderless, which we don't want. So, and is it only 1 pixel? Yeah, I think so. Okay. Or at least it seems like 1 pixel. Okay. Let's do const expression, float, panel height. Let's do maybe 100 pixels. No, it's transparent. Yeah, it's fine. Let's see, style var. Style var. Alpha. ImGUI color. Push style color. What's the best function to change ImGUI background color? Okay. Is it just style var? Do we have count? Okay. Window background. Push style color. Let's do black. Black for now. Solid black. Well, we end up with a black background for each of our, and it's not transparent anymore. Can we actually do? Let's see. Hmm. Let's just try messing around with that. Let me see what the style is. Create, initialize, GUI. Oh, we already set the style color dark. Okay, so window background. This is the default 0.94, and then there we go. So this should be, yeah, we have a black bar down here, and we have our normal controls. Okay. on GUI images. Let's see. On GUI images. Image. Okay. Texture ID. ImGUI texture. Okay. Okay. All right. So I basically let me show you. So basically, all this is that, and I'm probably gonna do it myself anyway. Uh, yeah, we definitely don't need this. Yeah, so this basically is a regular file read. Okay, so we do a allocation here. Oh my lord. Yeah, I should probably So this is basically binding a texture to ImGUI. Okay. Okay. This is going to be more cumbersome. We don't need all this. We already have, I guess, texture loading. We could use the ImGUI to load PNGs from file instead of DDS, but right now we have the interface for it. Uh, oh yeah, this is going to be very, very cumbersome. Yeah, so this maps onto a underlying thingy. Okay, let's add image, push texture ID, and then and inside our renderer. Is it this? No, it's not. It's actually in the GUI end, I think. I'm GUI render. No, it isn't, is it? Is it in the backend? I think. Could I do a call? Vertex buffer, blah blah blah. Yeah, I don't think this is. I'm not sure. Well, whatever. Yeah, okay. So texture handle, get texture ID. GPU descriptor handle. Yeah. So basically, if we walk all the way down, this simply adds a potential rect, add image, and add rect. Yeah, we add that. Push texture ID. Yeah, so he's basically he adds a draw command. Yeah, so we simply get a void pointer. It's a void pointer. Oh man. Hello, how are you doing? Oh, this is cumbersome. We kind of like need to fetch a pointer to a we need a sort of pointer to Okay, this is the loading. This is the drawing. Yeah, so this thing here is needed. I mean, uh, we could do something like super weird, where our renderer front end returns some stuff, but we could also just okay, let's do some stuff here, which I'm not sure is going to be how I like it. Eventually, get texture, GPU address, const. Yeah, I'm sorry about that. I don't speak Russian. Okay, let's try implementing this even though I don't like it. Should not, should probably not be implemented this way. Or maybe, maybe, let's see, our GUI. Does this actually use our GUI? I mean, the renderer itself could pass back an address. Uh, so our renderer here for our textures could kind of like store a GPU address, like something like a void pointer GPU address. Yeah, let's do that. And then static void pointer texture address, get texture address. Static inline constant signed int index return null pointer right now. Okay, let's do that instead. For functionalities, what do you mean? Okay, unload texture here. Call say create texture with the texture struct here. So inside our backend, we actually have a texture reference, and we can set our texture reference here. GPU address to our thank you very much. Nice to have you here, dude. Yeah, I'm only using C++ and DirectX for now. I might do some Vulkan stuff in the future, but right now I'm only doing these two things. So I think the ImGUI backend wants a GPU handle pointer, and since we kind of like yeah, okay, so we can ask our heap descriptor heap here. I have a tutorial, a beginner's tutorial about Directx12 here on the channel. Check out the playlist, your first Directx12 application in C++. There's also a GitHub repo for each episode, so that should at least get you started. I think no problem, man, and good luck. But do you know DirectX 11 or OpenGL beforehand? Because if you're new to graphics programming, I would recommend starting with either of those. And it should already be created here. We can't use the cube map. Let's just cast it. I can't. Ah, okay. Maybe you want to learn OpenGL then. Let me see. So this learn OpenGL. This is really great in terms of an introduction into game programming. What did I do? So let me see. Let me just post it in the chat. I need to. Here we go. Okay, so I can actually. Well, a void pointer is sort of like a uint in terms of systems anyway. I guess I could get this to work, but I'm not gonna bother. Okay. Well, it is basically the same. I'm sorry, dear compiler. Just interpret the bits. Oh my god, do I need to use static cast or whatever? No problem, man, anytime. Or should, oh, wait a minute. This is because this is a struct. Let me jump back into the thingy here and do a void pointer. Void pointer. I'm trying to force it into doing something. Let's see. Descriptor handle. Dot pointer. Dot pointer. And there we go. And just cast it to a void pointer. Yeah, so an integer can always be converted to a pointer. Okay, so thank you, man. Thank you and welcome. Let me just test some stuff here because I think I actually should have implemented. Oh, whoops, not the. Didn't I? Oh, maybe. Okay, never mind. I thought I had implemented some stream stuff. Just a sec. Let me just finish up what I want to do here. Okay, so we get our address stored in our front end. So let's return. Yeah. Yeah, I need to fix this. Dot GPU address. Okay, so this is a interface. And let's see our application. Whenever we create our textures, not materials. Okay, so Skybox is the first one. So we're 0, 1, 2, 3. So let's try using test as our texture. So it's just 1. In our build system here, let's include our core rendering renderer. And let's try doing image core renderer. Get texture address for the index 1. And then let's just do 50 times 50, right? And the next one is the, oh yeah, tint color, blah, 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 border color. Okay, let's try that and see if everything compiles. So as you can see, we actually have our texture here. So if I change this one, uh, we have a different texture, and then we can do our thing here. Yeah, okay, but we have a DirectX problem here. All right. Oh yeah, okay. So we need to force it to change the descriptor heap as well. Oh, ImGUI, you're making this tough for me. Okay. What's up, buddy? How you doing? Maybe we just want to bind our I'm working on this project here. I'm trying to make ImGUI use my backend for textures. So whenever we initialize the backend, okay. Okay. Let's maybe create a second one. So we still have our texture here, but yeah, the descriptor heap is different. Yeah. Okay, so basically, okay. So whenever this is set, we can't reference a descriptor built in another heap. So I guess I need to figure out how ImGUI actually shade a resource view. Uh, So basically, um, yeah, so inside our backend here, the problem is that we also need to bind a. Okay, well, I guess we could just do something like this. We will let ImGUI maybe. Let's do a parameter here. Define ImGUI num textures. Let's do 10. And then we will do 1 plus. Yeah, right now we actually allow 20, right? Yeah, so that's fine. Okay, so our backend will then, whenever we create a texture, we won't do it for a cube map. So basically right now we won't be passing back the pointer itself. We'd want this descriptor heap here also to create a descriptor for the resource. Where did we go? Not right here. Yeah. Okay. So let's create a create shader resource view here, and we still do our resource get, and we do. Let me just paste this, and then grab this. So get CPU handle plus, and then right now plus this. So in our descriptor heap for ImGUI, we actually create a what do you call it? ImGUI uh, we create a descriptor on the ImGUI specific descriptor heap. The first slot is reserved for the ImGUI font texture, as far as I remember. I think so, at least. Usually it's just one, right? I mean, yeah, the first descriptor is used for the built-in font stuff. So yeah, since we already pushed this, we emplaced back here, so it's already increased in size. Okay, so I'm just thinking about whether the ImGUI implementation for the backend here. So this sets the ImGUI data, but whenever ImGUI this implementation here gets called, yeah. Let's see. So this is the implementation itself. We could actually, yeah, do we actually, does he store the handle increment? No, he doesn't. We could do modifications to this. This is fine, this is fine. This is fine. So what I'm contemplating is whether we could store our addresses in this structure instead of on the textures. We could also just pass them back to our texture to our front end, but do we really need to? I mean, whenever this gets called, where did I go? I went down here. So this descriptor here, setup render state, render draw, backend data. This is for the index buffers, blah blah blah. Let's see. Texture handle. Yeah, so did this get text ID? So we grab back the ID, which is just a void pointer, to the GPU memory address. So if we grab this and know how much to increment, are we allowed to do ImGUI calls here? Yeah, I am. So ImGUI implementation is actually okay. So does it? Yeah, descriptor heap. We can do some hacky stuff here if we want to. Okay, so as long as it's created, we can actually, yeah. Okay, let's try this. I don't think we need to do modifications, and I also don't think the renderer front end needs to do what we just did. Yeah, so inside this struct, I don't think we need this. And we simply just create the resource here on the descriptor heap. So now it's both bound to the descriptor heap in ImGUI and our own descriptor heap. And this should compile just fine. Right now we won't be able to do this, and we need to modify our build system here. Okay, so let's do include this ImGUI implementation here for Directx12, and we're gonna do some real hacky stuff here, only because ImGUI is a bit bothersome to actually use. So we will do ImGUI get backend. What did we? What does it? Yeah, there we go. This doesn't work, or what? Isn't it? Uh, aren't we allowed to do that? Whoops. Aren't we allowed to? Data. Oh, maybe. No? Oh, we're not actually allowed to make that call. Oh, okay. Uh, Yeah, we would need to eventually make a custom version of this. But so this function is internal and we're not allowed to uh, actually use it, but we could. Oh yeah. So I would like this function here to be basically like this, and then do something like ImGUI implementation API. Not a void, of course. This makes no sense. There we go. And let's do a struct. I mean, isn't this fine? If I did something like am I not allowed to do that? And if I move this in here, no. Where's the syntax error? Oh, wait a minute. The problem is not inside ImGUI, at least for now. It's in here. And everything still works. At least I think so. Yeah, everything works. Okay. So we modified this to be able to grab our pointer to our implementation data. It's a bit hacky, but I guess we still need the increment size. Yeah, for the device. Maybe data does have. Let's see. Data. Yeah, it should have device. So we can do something like this. Why aren't we allowed to do that? Incomplete type. We should be fine. No. Oh, it's because it's not in the header file, of course. So it can't really understand it from the header file. Okay. We aren't allowed to do that. Or what? Oh, my lord. Max. Okay, these modifications are really, really cumbersome. Let's revert this back. I'm not gonna bother with rewriting ImGUI static. Okay. Yeah, we need a more elegant fix for this, but I don't like it. Circular dependencies and whatnot. Okay, we will just do it then. There we go, should be fine. Okay, let's see. And inside our builder system here. Does everything compile again? Yeah. Okay, but our texture is gone, of course. Okay. So our texture GPU address will be set to this, but it's GPU at handle dot pointer. Void pointer. Okay, so we're back to the old kind of like hacky system, but yeah. So we don't need this. And we want our call regular. Get the first. Let's just try 0 here. Oh, wait a minute. Yeah, we need 1. Okay. And we're back at bracketed, but we don't have any DirectX errors anymore. Okay. I don't like it, but this is a silly coupling. Maybe I could just rewrite it. Okay, maybe we can do that instead. Uh, um, no. Can I do that? Const unsigned int texture index. And draw lists. Can I? It still wants the draw list add image, push texture ID. Um, and in the implementation here, and the texture ID is set to the setup render state here. Not initialize shutdown. Our render state. Viewport. And down here, texture handle. So this grabs the start of the heap. Okay, so maybe if I do, this will do almost the same thing. So if we trickle down, this should call our, this will create a rect, I think. Yeah, probably not with a specific texture or anything. I don't know. It doesn't matter. At least we don't have any problems here. So add image. Let's create a version where we do a const unsigned int texture index. And we do basically the same thing, although we can't do this. And we can't do this right now. Okay. So inside here, we can do this now. Texture index. Okay, we're getting closer. Let's do a look into the command header. Let's do a... So texture ID is basically... Texture ID is basically... let's do a unsigned int texture index. And which should be set to 0 per default. I'm just going to be explicit about that. Let's do push texture index. Texture index is unequal to texture. There we go. Okay, let's just keep on adding. Own version index const unsigned int index texture index. Yeah, let's create that. Texture ID stack. Do we need a texture ID stack? Maybe we don't. Maybe we just want to. Right now we will try this. Yeah, this is fine. Okay, so going through the call stack here. Should probably not be needed. This is created by me. Okay, and add image. Let's look up this one. Created by me. And let's remove this and yeah. Okay. And let's see pop. And let's also create a version index where we simply do a command header reset texture index equals 0. Okay, great stuff. So we do this. So now we actually add a series of indices to our thing, and then we should be able to do we even have a render state here? Do we have explicit DirectX context set? Yeah, so it's called context, the device, I think. Yeah. No, it's the command list. Can I? And the device is never used, right? I mean, device. Okay, maybe we can draw data. Oh, this is not specific. Okay. Backend data. Maybe we want a uint srv increment size added by me descriptor increment size. So whenever we initialize, which let's see, do we set backend data? Yeah, we do. Backend data, backend data. SRV device. Let's see, SRV now descriptor handle increment size. That's it, right? Yeah. So we store that in our context. And then in here, let's increment this context. No, not context. Let's see, what is it? BD SRV times key command. Not texture, text ID. Okay, so this needs a function inline created by me unsigned int. Okay, no, maybe not here. Maybe not here. So we stored it. We store the Where do we store it? So when we add our image here, we push an index, the command header. Okay. So get texture. Okay, so whenever we where do we use the command header itself? Let's see, push texture index im draw list. So where do we draw data, draw lists, command lists? Command header, and it right. So the draw list has a command header, which is stored inside this. So inside the draw data, which is this, draw data. Also here, draw data, command lists. And then for each of these, okay, command list. Okay, so if we access the command list itself, command header, texture index, there we go. Let's try that. So at least we don't have any errors or crashes. Let's try this. Okay, it doesn't work, but it doesn't whine a lot. So yeah, I think it might be related to the actual recording of the command. We simply swap it here. Yeah, and we need to do that. Yeah, we need to do that. Same thing, we don't need the ID stack, but we do need something like this. So where is it defined? Okay. Let's do onChanged index. Made by me. And we need a command header texture index. Yeah, we simply need an X here. Texture. Okay. Added by me. on-site int texture index. Okay. So add draw command. Draw command. Added by me. Okay. And then, yeah. Okay. And inside our implementation here, we should use the command instead. PCMD texture index. Let's see, static assert field. Huh? Oh. Okay. Yeah. Okay. Okay, so if we place it after the vertex offset, we probably are in. Let's see. Like this, right? Okay, and we're able to actually do this now. Seems it seems like at least okay. Oh yeah, it's because a 0 can be a null pointer, which works pretty great because we should never set our index to 0 because it will be the font slot anyway. So it actually ends up by accident implementing some error handling, uh, but it's definitely not something I thought of. Okay, so instead of all this stupid, ugly stuff on the renderer front end and texture saving and blah blah blah, we can simply um, do things directly through ImGUI with our modifications. We added texture indices inside the descriptor heap to work with our backend. So that's pretty great. Okay, turned out we needed a bit of a ImGUI modification, but it is what it is. Okay, so let's make a really nice icon here for our panel. So let's do something that is be 64 by 64, and let's do something really pretty here. Let's do a hand-drawn little house. Now, isn't that pretty? We want this pretty little thing to be our icon. So let me just save it and create a texture. So in our assets, icon. So let me open NVIDIA texture tools here, and let me find the asset we just created. Okay, our pretty little icon here. And let's save that as icon 1. DDS. Yeah. And let's just load the texture then. Textures, icon 1. Did I call it that? I can't remember already. No, not assets. Let's refresh this. Textures, icon 1 DDS. Okay. So this is the fourth one. So inside our builder system, let's set it to our fourth texture. Oh my lord. Well, okay. For some reason, the ImGUI doesn't want flipped textures, which is opposite of all our pipeline. The camera action? What do you mean? Okay, let's just redo the texture then. We don't need to flip it then, and we just do icon 1 here. Override it. Let's see. There we go. Now, isn't that pretty? We got a little house here. We got a little house here. Okay. Let's see. Size, UV, tint color, border color. And do we have some default values? Yeah, we do. Okay. Can I do some kind of alignment? Super 8, what do you mean? So it's 52 times 52. No, 64 by 64, right? That was the size, and we have 100. ImGUI position push. Let's do ImVec. Cursor pause. And let's do ImGUI set cursor pause. Cursor pause x plus maybe 20 just for now, and cursor pause y plus well, okay, so we moved it on the x. Okay, so we don't want to move it on the x for now, but we do want to move it on the y. We want to subtract our panel height. Let's do const expression float icon size equals 64. Minus the icon size divided by 2 plus the cursor y. Okay, not exactly what we want, but so the difference maybe divided by 4. Yeah. Now, isn't that beautiful? Does it create an ID? Oh, we can do a button that actually uses the whole thing. Okay. Let's do added by me, const unsigned int texture index here. Okay, this should be actually exactly the same. Okay, let's try that. ImGUI button ex. What did we call it? Image button. Oh, image button. Oh, we also need to modify that then. Added by me. Const unsigned texture index. There we go. Test. Let's do 4. Oh, it basically wants. Oh, wait a minute. Let me look up that stuff. No? Test. For icon size. Icon size. Okay, let's try that. Oh my lord. We have a button. We have a button. Let's see, can we do a ImGUI hover? Maybe it's style bar, color, blah blah blah. Hover. Frame background hover. Okay, and am I allowed to? Maybe I could do some custom widget. Let's see, tint, color. And we set background color. Let's try swapping this. Okay. Maybe if we set the tint alpha. What default? We have the UV stuff here. So inside our builder system, let's just do the UVs here then, the background color. And the tint color, yeah. Whoops. Yeah, then it will be transparent. Does this allow? Okay, so inside here we have a, yeah, it converts to floats. Okay, so I can actually specify floats here, make it semi-transparent. It's pretty ugly. It's pretty ugly. Anyway, and if we do it semi-transparent here, it seems like it's highlighting more and more, right? So if we do a very, very transparent, yeah, the highlight color gets more dominant. Okay. Push style color, the color index. Let's see, hover, button, header hovered, button hovered. Okay, let's see, in our builder system here, this is a lot of fiddling around, but these styles? Did it? There we go. So what's the hovered? This is the standard value. Okay, so we can do and then afterwards we can do a reset. Whoops, like this. Okay, so reset back to original style for window. Reset button hover back to default. Okay, let's try black hovering color. Let's see background color. And inside here, render frame, color. Oh, so that's the frame. Yeah, basically I don't want. Okay. Let's see if I click it. Okay. That's fine. But we could also do like this. But what is the default button is right here. Yeah, I don't like the color in terms of button active here. Maybe we should just create a style that is more us, so we don't need to do this. Okay. Let's just do a to-do here. Create ImGUI style. Okay. ImGUI call button active, right? Yeah. What do we want here? Let's just do some really green stuff. There we go. Let's just do a red one here and then increase this again, I think. Yeah, it does. Then maybe just a subtle gray. It's not so subtle, is it? There we go. And then decrease this a bit. Tint. Okay. Okay. So we've basically implemented that. Yeah. All right. So we now have some sort of, what do you call it, panel. That's done. Let's move it to the done pile. So yeah, I'm gonna do a small break, bathroom break, do some different. Do some different stuff, and then I'll be back at it. Yeah. So let me just leave this here, and let's see. I need to do be right back, right? Is this one? Yeah, I think so. All right, be right back. All right, I'm back. Let me see. Okay. Okay, let's move on with the actual build system here. So right now we have this box here hovering around our um this box floating around I don't know what you call it, our mouse. I'm getting distracted right now. Sorry about that. So we have this box. Whoops. Why did I do that? Wait, let me see. Okay. Um, so we have our box here snapping to our mouse. Well, first we should enter a build mode, right? Um, let's see if we disable this. When we click our button, maybe we want to enable this. So we have some ImGUI stuff here that we can do. If we click this button, we do something to the game state. And inside our game state, we could do something like uh, yeah, you can. If you watch my other series here on the channel, I actually try to do something like that. Let me show you. So if I open this DirectX12 game here, this game here is actually created entirely in C++ without any library at all. No libraries. Zero. And it has physics and stuff like that. An editor and let me see. Yeah, as you can see, different stuff. Yeah, so you could. It will take you a very, very long time if you have to do UI. So this game here uses ImGUI, and previously during this stream here we had to do modifications to ImGUI to make it suit our needs and use our backend. Let me see, let me just render a, let's add a sticky here. Icon specific texture loading for an interface with ImGUI. And we need to do that eventually because, yeah, the way the backend works right now is where any texture can be an icon, but basically the ImGUI layer should use only icons, and there's no reason to what do you call it, combine both textures and icons. Yeah, but I'm not gonna do that right now. So if we click the button, let's just do something like this, I think. So when we click this button, we want to be enabling some kind of like build system. I imagine that our build system will simply have a buffer. Um, on the game state. We could try doing something like that. So maybe we want something like struct builder building. Now, isn't that great? And we need a mesh ID. And let me just quickly grab the box ID. Debugging, no, not here. Let's see, in the mesh buffer. Yeah, so the second, which will make this the third, what do you call it? Mesh. Builder, building. Mesh ID equals 2. And then we create a buffer. Yeah, we will fix this eventually, but right now it doesn't matter. Not renderer. Builder. Building. Build. Q. Not Q. Build list. Builder. Current. Or. Well. Yeah. Let's just do this. Maybe this will allow us to do maybe not. Maybe. Okay, let's just start out doing this and then I might change it. Yeah, because right now I would like to click the button and then add an object to be drawn to an array, and I might click a button that builds two buildings. Maybe just rename this build holograms, build a hologram, build a hologram, build holograms. Maybe this will make more sense. Okay, build a hologram. Holo. Blum blum. And let's see, game state. Holograms, clear. And then okay. Yeah, so, and then push back this, or maybe just place it back. Let's move hologram here. Also, let's just add a quick way to deselect. Inside our builder system here. Game stage. We simply clear it. So if we right click, we will clear it. Okay. Let's try that out. So in our application right now, this is still debugging related. Let me just close this so I don't end up there. Then for game stage, builder hologram size. Well, maybe we just want for const auto reference hologram. Hologram mesh ID. Okay, so if we click down here, it immediately does that. So maybe we should be bound to the 3-click instead. Let's see. Let's try that. Yeah, that's better. Okay. How do you like that? And we can do some let's see, mouse 1-click. And build a hologram's size. And then let's just do GXE. Okay, we don't have common helpers here. Include call common helpers. Whoops. Try to build that stuff. So if we click here, I'm clicking, I'm clicking, I'm clicking, nothing happens. And if I try to build, you can see here, we do end up building. Okay. Or trying to build. Right now our logic doesn't do anything. Just checking out some stuff. Oh, let me just change this to live. Okay. Yeah. Okay. We still haven't actually implemented a what do you call it? Uh, um, yeah, we haven't implemented a hologram pipeline. So build a hologram here. So we have some information that we pass along, which we kind of like want to store in our Well, I guess. Yeah, okay. So we need our mouse position here in order to create our holograms. But we could do like something like unsigned int x offset. No, maybe int x offset, int z offset. Yeah. Yeah, let's try that. And when we draw our holograms here, let's look at our game state here. Tile. Okay. Tile. And you in 32 tile depth. Let's just copy these values. Then we do the x position minus this cast to a float. Tile width times hologram. Am I not allowed to? Oh, maybe. What? Okay, let's look into the hologram here. X offset. Let's do plus. Tile depth, Z offset. And let's do hologram load model scale. Let's just do that. 1. Let's play around with this. Model scale. This is the orientation. These are the textures, blah, blah, blah. Yeah, we need to, of course, when we, so the hollow model scale here is 0.5 for this model. Yeah, we need to make a more robust system, but Yeah, so but let's try out the offset function here. So then hollow offset -1, hollow or not on the C offset. Okay, so this should draw it on the x-axis. Oh, it doesn't work. Interesting. Why is that? So if this is 0, it's fine. If we do +1, okay, yeah, so it's type conversion. I think let's just do int. Yeah, so now it's to the left of the mouse. Let's see, and let's do a load model Y offset. Hologram model Y offset. Hollow C offset equals -1, and hollow model Y offset 0.5. Yeah. Let's just do pushback here and stop moving. Because we can then do something like mesh ID, but -1, -1. Let's try doing this. See how that looks. Look, it's gonna look weird, yeah. But my idea is that let's see, model scale is still fine. Yeah, okay, so it will be on top of the existing thing. So if we do like and let's do a uint 32 texture. And that's it. The last one is the texture, right? Yeah, so it's 2. Oh, sorry about that. If I scared you, surrounding. And we can do something like and then oh wait a minute, this, and then there we go. Oh, we need the last corner. Anyway, so this will be, oh, like this. So we can like do some kind of like area thingy. We'd of course need to do a different system for this, but yeah. Um, I think that looks decent, at least. It's of course not a robust system, but so imagine that this building had an effect on 9 tiles. Um, this would be something that got displayed. But of course we want to do instance rendering for all of these tiles here. We also need a kind of like pipeline in order to maybe render this in a different way. So maybe we should implement that. It's gonna be a lot of work. It's gonna be a lot of work. Let's see. Let's see what happens if I do that. Yeah, it will intersect, but we don't really care about that. Okay. Okay. Let's start adding room for a different pipeline then. Because I want this to be some kind of a transparent model which gets blended onto the whole thing. At least we could do that. Maybe you would even want a combination, like, but at least you would want some kind of like, I mean, the tiling around the model center should be transparent. So we could at least use that to render our surrounding area. Yeah, we can play around with what we like, what looks nice. But we do want a pipeline for that. And we're gonna play around with some blending stuff. Also, this is kind of like a transparent draw call, so it should be, if we ever end up doing deferred rendering, we definitely would want to handle it separately, but yeah, we should be mindful of whenever this gets drawn, because it's like supposed to be on top of everything else. And besides that, I think we want, for whatever draw calls we do, not to be included in our shadow map. Doesn't make any sense that we're supposed to draw this with our shadow map. Why should a potential building cast a shadow? Okay, anyway. Let me start with the actual pipeline itself then. Just a sec. Let me see. Let me see. Okay, so I was just studying my blend instructions. Let's create a series of shaders here. Let's do transparent polygons. Um, okay. Let's just move this around. Yeah, okay. I figured that we would run into trouble. Maybe this is the problem. So let's see, bind. Maybe I can do like this, and then do like here, this, right? Yeah. So it's whenever the root signature is created, it's related to that. So a bug from a previous episode. Just revealed itself. It's because this pipeline here doesn't use a render target, I think, or rather pixel shader, and it starts complaining about what is bound to that particular root signature. Anyway, let's do a transparent polygons. Let's add a shader for this one, vertex shader, and add a pixel shader. And let's not include them in the project. Skybox. Transparent polygons. Okay. Let's see if we have any trouble creating that. Okay. How on earth did that happen? We lost our skybox. Oh, it's because I override it, of course. I forgot that. Okay. Transparent poly pipeline. So we keep on doing that. Okay. And we're still able to do that. Okay. Okay, so we need to fiddle around with the depth comparison. So let's see. So the depth enable should just disable it all, right? Uh, yeah. So we could override that. Let's comment out all of this. So we haven't actually used blend mode 1. So false. So we will write it. And let's see. Initialize, use render target true. Root signature preset is the next. Then the blend mode is the next. So we have render target true. Then root signature is the first, number 1, and then we set this. Okay. Let's just do no. I would like to be able to test this. We don't need this. Rasterize mode, we don't. Do we need to set the rasterize mode? No, we don't. Yeah, we should definitely make this more readable with some enums, but or maybe just some flags, but I don't know. Yeah, I would need to refactor the whole pipeline stuff, but I also think that under certain circumstances, I would want to modify the way that the shaders are compiled anyway, so yeah. Anyway, so let's set up our pipeline state here. We should end up in a situation where we don't do depth writes. We don't want for this to block anything. Okay, we need to add some blend state. Alpha to coverage is false. Don't want this pipe, this pipeline to write to the depth buffer. Let's see, independent depth enable, I can't remember. Blend enable, not this one. Yeah, we're only going to use this one, so this is also false. And let's do and Whoops, I did something wrong. And we simply enable blending for the primary render target. Let's see. Okay. So let's see. We definitely want the let's see. The destination alpha is just going to be 1, I think. Maybe we... Okay, let me see. Let me look at the blending equation. I'm not good at this. Okay. Can I see the blending equation somewhere? Okay, so destination blend. Let me see. Yeah, okay. So destination blend. I think alpha factor. I need to Yeah. Let's see, destination, invert. And source blend, blend source. Let's see. Blend source alpha. So we take the alpha from, no, no. So we take the alpha from this source pixel and we take the inverse of that for our destination. So this gets multiplied. And our destination pixel or our current render target pixel gets eventually multiplied by the inverse alpha of whatever we're trying to render on top, which is supposed to be transparent. Let me see. And we will be doing addition. We'll simply add them together. Blend up, add. Yeah, okay. So if we combine the alpha channels, since we're doing yeah, okay. So this is for the pixels, then is let's do destination blend alpha. Let's just do a 0, blend 0. Let's do a source blend alpha, which will be uh, D3D12 blend 1. And let's just do a add here. Blend up alpha, add. So we simply handle the alpha channel of whatever pixel we're handling by resetting the destination alpha to 0 and setting the source alpha to 1 and then adding that. So we will end up with an alpha value for each pixel with 1. But for the actual colors themselves, we do use this algorithm here. So the colors are multiplied by for the source or rather the render target pixel with the inverse of the source alpha, and then from our pixel shader, we will use the actual alpha and multiply the color by that. So this should be fine. We did logic enable, right? No, I don't think, no, we didn't. Logic up, no up. Okay. Take the current pixel shader color and multiply it by its own alpha. Take the previous pixel in that slot and multiply it by the inverse of the current pixel alpha. Then add the colors together. Okay. Okay, so I think this is fine for our transparent pipeline here. Inside the vertex shader, let's copy most of this to our vertex shader here, since we will basically be handling pipelines like that. Mostly the same. I don't think we will use the lighting stuff for this, but let's uh, let's try removing all of that. Okay. And we could try uh, hmm, Let's see, transparent objects. Uh, let's see. M transparent polygon pipeline. Am I allowed to do that? I think so. Yeah. Okay. Um, um, okay. So we should start trying to start drawing something. Yeah, we could clean this up eventually, but right now we are going to be explicit about everything. And I want the pass data to be set as well. Yeah, we need to also do some C sorting before submission. Okay. I'm gonna do a quick bathroom break. Be right back. me just change the music here. Um, okay, so whenever we do this stuff here, we want to like write to a yeah. Game state is not probably not the correct thing. Yeah, for rendering. I'm not sure it's supposed to be coupled to that. Okay, so our application needs some kind of game types. Builder holograms, blah blah blah. Camera is fine. But these things here should probably be moved. So we could do a struct here. Render data. Render data. Let's port this into this. Yeah, because render data. So that's the first part. The renderer itself should, instead of a camera here, resource types, run over mesh. Let's do draw params. Render draw params. Or maybe just front end. Render front. Does this include camera? No, it doesn't. Maybe we don't want it in here then. Maybe we want it inside the renderer. Renderer params. And we could move. We already need to include it in our application because we call it. So, yeah. So submit and draw. Pointer. Let's see. Renderer params. Params. Maybe even flip them. Okay, so this is the parameters. Let's change this. And let's do params.camera. And let's see. Let's do core renderer params. Draw params. Draw params camera. Gets a reference. And let's do draw params here. Oh, that's because we're outside that scope. Okay. So this should still work. No, not yet. Game state. Okay. Where are we? Where's the problem? Oh. Yeah, I think it makes more sense that whatever buffers we're using for rendering is somewhat separated from the actual game state. We don't need to pass a pointer around to that massive of a struct. Maybe even no. This is related to the game state. We're just interpreting render data from it, but yeah. Okay. So what we can do is we could do something like we could do for indexing into render groups. Maybe we even don't need to pass that along. But in here, let's just do something temporary. It might not be this way in the end, but maybe we do something like unsigned int solid polygons. Unsigned int transparent polygons. And let's do a vector of unsigned int sorted transparent indices. Okay. Let's try doing that. Okay. Renderer draw params. Build parameters. Draw params. Solid polygons. Mesh buffer size. Draw params. Now this minus this. Okay. So inside draw params, we do rewrite this for unsigned int I0 I less than params dot solid polygons I plus plus. Let's see. Renderable mesh. Drawable. Does this actually return a... No. Okay. Draws I. Let's do drawable mesh. And let's do okay. So this should keep on drawing our solid meshes. But if we click this, nothing will happen. And let's see frame data. Buffer indices. Solid polys. Transparent polys. We copy these parameters to the backend. And inside our backend, we can access them. So we could basically just create them all. Yeah, why don't we do that? Yeah, why don't we just do that, actually? Why don't we just do that? Oh, wait a minute, because we want this sorted stuff. Because we want this sorted stuff. Oh yeah. Oh, I is equal to this, maybe -1. Yeah, I think -1. And then we do I list and params dot transparent polygons. Let's see if we have a bounds violation, but I mean, this should be right, right? And let's see. Yeah, simply let's basically just copy this for now. We're not really doing anything out of the ordinary. Nothing happens then. Oh, yeah. Huh. Why doesn't anything happen? Let's see. Yeah. Let's see if size, let's do gxe print state enter, and we can debug. Okay. Let's see. In our renderer here, where did it go there? Let's just disable this for now. Okay. Oh. I'm using that wrong, I guess. So it's not related to this. ImGUI pop style color. Maybe we don't need to do this then. Three? Okay. Let's see. Okay. 1, 2, 3, 4. Let's do 5 and then. I really don't understand. Okay. So this needs to be 1. And then inside here we need 3. Is that it? No. Push style. Oh, ImGUI. Let's see if I don't do this. And I don't do this. I still end up in the wrong spot. Why on earth is that problematic? If I don't do this and don't do this, I still style var stack. Is it because I in this simulation do something or what? Let me just see. I don't know what that means. No, I don't do any of that. Maybe ImGUI pop style var 1. Okay. And what happens if I enable this and enable this? Then we're good. And if I enable these 3, okay, we do end up in a bad spot. Oh, because I didn't. Oh, now I see. I didn't disable that. Okay. So we're we're back in business. Let's see. Did I disable my rendering stuff? Yeah, I did. And inside our application, there we go. So nothing happens. Why is that? Okay. So 50 polygons. Nine transparent. Let's see. Okay, let's step out of this one and disable this for now. If GXE print enter state. Huh? Oh, solid. Transparent, of course. Okay. So let's see, 59. Oh, it just skips. Oh, yeah. And now I know why. Stupid mistake. Stupid mistake. Okay. So we're back to rendering that. Should be sorted by C ordered indices, but we'll implement later. Okay. Let's do, should maybe okay. Actually, I want these parameters to be flipped. Even though it doesn't matter. Let's see, and this should be const. This should also be const. Let's see. Okay. Yeah, of course we need to flip these. Oh, wait a minute. Oh, no. That's for the mesh stuff. Okay. Okay. Instead of doing this, we do access our frame data. Solid polys. Okay. And nothing happens. And next, we want the same thing. This should be unsigned. Unsigned int I equals solid polys -1, and then I less than plus frame data dot transparent polys and I plus plus. And let's just do this for now. And this should basically mean that, oh, ah, let's see, I should get a boundary violation here, right? Yeah, it's definitely not working. And also this should make us, no? Okay, that's weird. For some reason it doesn't render the last part. Why doesn't it do that? Okay, let's try debugging that. I have made some stupid mistakes somewhere, I'm pretty sure. Print, enter state. So let's see, frame data. Nine. Let's see. And package 60. Oh, so we don't get to the last one, I guess. Let's see, package. What's happening there? Do we draw the... Huh? Okay, so this is the box, and then 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so we're not submitting the right amount of packages, I think. Okay, let's just try commenting out this and re-adding the draw package size. Yeah. Okay, so this actually does create the front end does create correct amount of polys. So this is the old one. This is the new one. What happens if we do like this? Is it because we don't? Oh, the I value, of course. Yeah, so the buffer data themselves are not getting created, I think. Okay, so how are we going to do this? Maybe like this? Yeah. -1. Right? Yeah. Let's see. Okay. Total amount of packets dot size of which solids and transparent. We don't need to do that, but we could do start index, then '60. So they will run from 0 to 49 should be 0 to 49 should be our draw packets. What's wrong with that? Okay, maybe I'm creating one too many here. I think I am. Okay. Let me see. I think this is the crash, right? No? Okay. Okay, so let's see. It's not related to this or what? I'm pretty sure it is. Yeah. Yeah, we ended up adding one too many. And this should, of course, not do this because then it will run once. There we go. And we need to remove this. Let's see. Pack doesn't take any time. Let me just show you. Pack doesn't take a very long time. Yeah, R% and blah blah blah. Yeah, the draw commands themselves are the rest of whatever we're doing, and everything outside the actual draw is not really affecting our frame rate. So, okay. Okay, we don't need to check the packing then. Okay. Okay, so we have our old stuff here. Okay. We don't need the pipelines right now. We don't need the ImGUI specifics. Actually, we don't need to look up the things we're doing here. Okay. std vector ex vector dx draw call transparent poly draw calls. Okay. We're getting there. Now let's see. Let's just do the same for the transparent polygon pipeline draw calls here. They are basically the same. And we have some trouble since we're getting a what do you call it? Error message here. Yeah. yeah. And does it can and will? No, can lead to unexpected behavior. Okay, so the problem is now that if we rotate the camera, uh, maybe we don't want a call mode actually. Let's see. Pipelines. Let's try doing that just for funsies. Doesn't change anything, does it? What if I change the pixel shader here to just return a solid white color? Yeah. Okay. Maybe it's RC ordering here. I don't know. But we do have some I mean, is this related to the angle? What's the issue here? I see the texture dancing around. Now that is weird. Oh, I don't. Maybe I need to. Oh, that's a weird bug, isn't it? Let's see. Pixel shader, yeah. And it's not because I set some weird value for the material, right? I don't think so. Am I draw? Oh, maybe I'm drawing too many objects. Maybe I'm actually drawing multiples. Maybe I'm actually drawing multiples. So let's see. Yeah, the data is not stable for some reason. Let's just step into here. $49. Yeah. So whenever I upload the frame data here, I mean, if I disable this, do we still have the flickering? Actually, we do. But it's only for some of them. No, it's for all of them. When does this bug get introduced? Because I don't know. I don't think it was there before, but I can't. I didn't realize when the actual bug appeared. It's definitely not right. Let's disable all of this. Shouldn't be it, but yeah, it's still jumping around. I mean, flickering, right? Look at it. Why is that? It's almost like I'm doing double the work, right? We're only doing one instance. Huh. Okay, let's see in render doc what's happening. Okay, color pass. So let's see. It's not related to blending of some sort. Well, is it? So we draw all of these, blah, blah, blah. Hmm. Render target. Let's see. Texture, swap chain. How come does it why is it different? I mean, what's happening? It's not supposed to do that. Change the I mean, see, each draw call is like changing the pixels of Huh? Did I? So from this, something goes wrong. Something goes wrong. Uh, let's try disabling the build system. Maybe I messed up some of the pipelines. I don't know. Simulate and build. Disable that. It still flickers, so it's not related to the building thingy there. It's almost like we're getting wrong data. Do we need to, do we clear somewhere? But we do that here. For now, let's just disable this stuff up here. We didn't mess anything up when we camera pointer. It's related to our solid stuff. Huh. Let's see, pipeline state. What's the default? It's back, right? Yeah. Did I change something in here? And when, I mean, right now we're not using that, we're not using that. So, yeah. Let's try disabling that pipeline. Just to see if that changes anything. Oh, we're still messing around here. Is it because of wrong bindings? Polyvertex buffer. We do have specific bindings. Let's try disabling the skybox just to see if that matters. It shouldn't, but we might as well try. Nope, nothing happens. Let's do disable the shadow pass as well. We're still messing up here. Is it because... No, I didn't change the UVs of this. I didn't change, I only changed it on the, what do you call it? Okay, so it's not related to the shadow pass. It's not related to the skybox. It's probably not related to the what do you call it? Yeah, is it? Is it related to this? Nope. That is so weird. That is so weird. That is so weird. When did we actually get that bug? When did we actually get that bug? And inside. And our standard is funkless. Uh, oh my god. Is it because of constant buffer overflow? Are we sampling? I mean, 200 and it shouldn't be doing that. It shouldn't be doing that. Okay. Let's do 2 columns. We still end up in trouble. Let's do 2 of these. Oh, maybe it's 2 times 2. Ah, maybe we're onto something. So when I change this, yeah, maybe. So whenever I submit it for rendering, okay. Let's do then. It's already a problem, right? If I only do 1 row, I still end up in trouble. But it also looks weird because now I know. It's because of the scaling. It's because of the scaling. So this is supposed to be 1, but it's, yeah. I think it's because of the scaling. Okay, so yeah, that's also why the texture doesn't fit anymore. Okay, so if I set this back to 8 times 8, And in our application, we scale down the thing here. We at least don't get any flickering, right? But the spacing itself is not good enough. Let's see. We end up, yeah, so it's related to that. Huh. So at least we're not overlapping now. And this is kind of like minus 0.5. Minus 0.5. This should not be called Y. I think it's misleading. Let's see, 1, 2, 3, 4, 5, 6, 7. And then we're back. Yeah, okay. This explains a lot. I thought this was weird. 1, 2, 3, 4, 5, 6, 7, 8. But I don't know why. Why do we end up with so many AABBs? Are they overlapping as well, or what? 1, 2, 3, 4, 5, 6, 7, 8, 9. But now this is some weird bug, right? Oh, it's because we no? Huh. This creates the correct amount of draw calls. So let's see, 8 times 8. 8 times 8 is 64, of course. Okay, let's enable all of this stuff here again. It's not because we didn't do things correctly here, it's because we introduced a bug somewhere. Oh, I understand now. It's because, yeah, let's just redo the AABBs afterwards. Let's just redo the AABBs afterwards. Okay. Let's not do that right now. And it should be fine, right? Oh, we do end up in trouble. Oh. Okay, instead of doing that and accessing that area, let's do a tile Y. Let's do a float Y. Whoops. Float Y. And then uint C. Okay. We don't need this. C. Tile Y. Okay. And inside here, we do minus this. And then simply split off this. Huh? Oh, okay. Cubes. Let's not do that right now. Okay. So we're at 1, 2, 3, 4, 5, 6, 7, 8. Okay. Let's reintroduce the AABBs. Then 4 const auto reference tile in game state tiles. We do a ABB. And we do a center. Oh, let me just redo this then. Let's move it. Then for const auto reference tile in game state tiles. Oh, whoops. Tiles. We set the thing here. And this center to times tiles dot x, and then tiles dot c, and we simply push it to the vector. Yes, it does create some stuff. It's not really how we would like things. Okay. This is because they're scaled too big. I think so. Yeah, remember we stopped scaling things, right? Yeah, and then their center needs to be offset. So that's basically it. Let's see, let's try printing out GXE call print mouse at position X. See. Okay, so let's find the origin. So, is this the origin? Let me just move this so I can see. So, this is -1. This is somewhere around the origin. Let's see, can I? This is actually the origin. This is somewhere. Okay, so one of the corners are actually at the origin. Okay. So let's make it so that whenever we are rendering the stuff, let's not subtract anything. Okay, so for some reason, I mean, the origin is where? Yeah, so it's 1 times 1, so this could somewhat make sense, right? Yeah, so this is the origin. This is fine. Okay. So we don't need to do that. In terms of scaling here, so we're actually scaling this down to half size. So one tile is exactly 1. There we go. Yeah, so right here is the origin, and this is 1 by 1. That makes sense. Okay. That makes sense. So it was C fighting from offset there. Thingies being rendered. Okay. I didn't even notice the bug. Okay. So our bounding volumes are just basically following our stuff. They're a bit too big on the Y. No, they're not. They're not. They're not. They're not. Okay. Okay, I disabled this simulation stuff. So let's add that back in. Let's move that out of the game loop area here. I was just fearful that we ended up in a bad state because of some of the new implementations, but it seems like nothing wrong with that. It was just calculation of whatever. Okay. Okay, and inside our builder system, let's add that. And where did we then disable stuff? We disabled our rendering of this. And it should still be C ordered, but I think we're up and running here. And yeah, okay, so we have a problem with our coordinates now. They're messed up in terms of snapping to the grid. Also, I need to figure out how that blend mode stuff should work. Let's not add that. And we're back. Okay. Yeah, I'm wondering how to order stuff. Okay. We need the ordering then of whatever we for whatever we want to draw first. So we should do something like it's probably done in the correct order, but let's do some C sorting. Maybe even just float C's. Let's see, C's reserve. I know this is not fast, but let's do like this. XM vector position equals hologram dot let's see. Basically this. We could also buffer this. Yeah, we could buffer it. Could be buffered for later storage. Anyway. And then the CPOS and then 0. Maybe even, no. XM matrix cam view pointer equals let's do it on the draw params up here. Draw params camera get view matrix. Let's see. XM store load 4x4 a load float There we go. Let's do CZ, pushback, XM, transform, XM vector, transform, position times the cam view dot the C component. So whatever is the furthest, this needs to be the C component. Then, yeah. So let's see. Okay. If DXE call print enter state. And CZ. I can't remember. Yeah, so I think the way we're doing in the build system here, we're creating the one that is furthest away from the set. So let's see. Okay, let's try. So we saw that the first one is the general mesh. It's not as far away as the C, or rather the next three tile squares. So what if we rotate the camera here? Then, yeah, as you can see, we end up with a different C component. So, okay, so we need to find some kind of sorting algorithm here. Fast sorting algorithm. Low to high. C order. Okay. Let's see. Yeah. Okay. Okay. We could just do a naive approach, right? Um, well, okay. Okay, a radic sort. We can't use that for floats, right? Oh, that would be, I don't know. Maybe we could, but we would need to grab it from the let's just do a stupid sort here. Okay. What kind of sorting algorithm do we want? Mm. We could also just do maybe just do sort. Okay. Okay, okay, okay. Let's try doing something like let's see, where did we? Okay. We will do something here, at least temporary. whoops, utility. Tick, blah, blah, blah. This is not needed. Pre-game. Let's see, std pair unsigned int float. And let's see, let's do unsigned int I equals 0, I less than this, size. Let's see, build hologram, hologram equals this I plus plus, and let's do this. Okay, and then I and place back. There we go. So we create a series of pairs right now, which contains our original index and the C value from the camera perspective. Sort a vector pairs Okay, let's see. So let's try doing this. We might not. std sort in algorithm and let's see our beginning of our vector and our end of our vector, and then a lambda function here. Sort and the const std pair unsigned int float reference A and then B. Let's see. Return a.second larger than b second. Does this work? Okay. If size exe print test. And let's see, our CZ is ordered in this way. Okay, blah, blah, blah. Yeah. Okay, so we actually get things sorted. Let's see. We don't need to enter state here. Also, yeah. We're doing a sort here. Okay. And then we need to disable this. So we need a for const auto reference pair in CZ. And let's do hologram go. Does it even matter? It seems like it. But for some reason, it doesn't draw the front face, right? Does it? By the way, is it floating too high in the air? Yeah, it is. So let's try swapping this. Oh, it's probably related to that. Oh, it's negative, right? Or what? Yeah, it is. Okay. Never mind. Never mind. Never mind. Yeah, it's definitely floating, but I can't really. I mean, okay, let's just save a screenshot. So I do a screenshot over here where I compare. So it's placed right here. I don't move the camera. And then let's do a different sorting algorithm. I'm unsure whether it really makes a difference. Okay. But let's see. Let's say that this is our new perspective and I disable sorting. And let's see. Doesn't really matter the way it's blended. Maybe it will matter when we use different textures. Yeah. Yeah, I don't know. Okay, let's disable this for now. This is based on sorting, and this is just straight up drawing it. Yeah, so I guess I would want to create some kind of texture for it. Okay. Yeah, so I need to implement the pixel and vertex shaders. Yeah. Okay, let me see. Oh, I've been streaming for almost 7 hours. um. Yeah. So I'm probably gonna do a good old break, maybe even for a little while. Yeah. So at least now we have the option of actually rendering transparent stuff, and we can do um, several. We can do more than one render group. Let's see. This should be. Let's see. Let's just fix that when we create the and. Is this supposed to be negative even? I don't I don't know. Maybe divided by 2, right? No, the half width itself should be. So What happens if we just set this to 0? The mesh itself is then above mm, 0 minus half width stud y divided by 2. No, yeah. I mean, no, it's correct, right? Yeah, I don't know where 0 is actually. So, I think this should be fine, right? And we're back at whatever offset. Yeah, so it should be. I don't know. Yeah, this makes sense that it's placed on the y-axis according to its radius. Let's just create it at 0, 0. All right. So that makes sense. So the 0 point is down here, and this is offset. Okay, okay, okay. And we can do some building stuff. And in our builder system, let's see. So this should sink it down into the thingy, yeah. Let's see, a hologram, model scale, load. Yeah, this could be a Directx float 3 instead. Uh, let's do a 0.10f and then like this. X, Y, and Z. Maybe even is it even what's happening? Seems a bit. No, was it just? Well, there's a bug somewhere. It's kinda overlapping, isn't it? And also maybe we need a different depth comparison here. Yeah, we don't want to overwrite, so we should probably not in pipeline header, but in here when we set up our, no, not here, inside our renderer. There we go. Backend here. Transparent. Call mode. Back. Let's see if that changes anything. Just for starters. And then less equal. Right? Maybe just. No. Maybe. Depth compare. Let's see, depth stencil here. Zero. Yeah. So we will enable depth testing, but we will set the rather. We don't need to set this because it's already set. PSO description here. Depth stencil. Depth right mask. 0. We won't be writing any depth information with this pipeline yet. So as you can see now, we have proper clipping. So that was the problem before. We kind of like ignored the depth check for these pixels. So we rendered them to the screen no matter what, and that looked fairly bad. Let's see. Do we want depth testing? No. I'm pretty sure we don't, right? What other settings could we set? Yeah, let's try doing that. And then inside our builder system here, we or rather change the model offset here on the y-axis. And then we're kind of like floating above here. Maybe what happens if we just set this to 0? Will we be mapping it exactly on top of it? It almost seems so, right? So this way we can actually place this stuff here. Yeah, we definitely need to check whether the sorting algorithm changes the effect whenever I actually do the pixel shader itself. Okay. So the idea is that I'll change the texture that surrounds the objects around the whole thing. Let's just enable some texture sampling for now inside this pixel shader here. Let's do the thing here. Where we return that. Return, whoops, just this. And that looks pretty funny, right? And let's do, instead of doing this, we will do float 4, diffuse, and we will set the diffuse dot alpha to be 0.5, and then we return the diffuse here. Now that looks pretty great. So let me see. If we enable the sorted algorithm, C-sorted algorithm, how does this change? Oh, let me just compare to with the screenshots. So I need to actually open Paint here and then do a screenshot from this angle, because I know this angle here makes it resort the draw order. It doesn't necessarily do it on the in the ordinary way, or rather at the original angle. Oh, X. I changed this Y and Z. Okay. And let me compare that. doesn't really seem to be mattering that much. It doesn't really seem to be mattering that much now. Maybe I just can't see it. I mean, maybe at some odd angle. Because there's no reason to. Actually spend computing power on doing that if it doesn't make any difference. Okay. Wow. Uh, and what happens if I actually enable the depth right? Ah, I actually like that better. Right. Maybe the sorting algorithm then needs to be implemented. Okay, let me save a screenshot first. This is the screenshot, this is the wave, and then yeah, it doesn't really matter. Let me see. So I can't see whatever is behind it, right? I can't see through it, I can only see around it, I suspect. And that's probably not what we want. Okay, no depth right. And then, because maybe we even want, I mean, swapping pipelines all over. I mean, we do get these. Maybe we should use a different model for this. One with different texture mapping. So that the sides themselves are transparent. But, so, let's consider this. So we have this as our comparison, right? We kind of like have a solid middle object, but we can't see whatever is behind it. And then we have a fully transparent one where we can see whatever is behind it. I'm guessing this one is better, right? The other one is weird to look at. So we will have the depth buffering here. Okay, so great stuff. Yeah, and it doesn't seem like we need to do the C buffering, right? Since we actually have GPU-based C buffering with the depth buffering. So yeah, let's just add this to the graveyard. No reason to use that. And I think this hologram here is pretty good. So whenever we want to build something, we kind of like do that. Great stuff. So we now have dynamically generated holograms. We could even give the different parts of the hologram different textures if we wanted to. So that's pretty neat. Let's just create a simple texture here. Maybe we do something like this for our 64 times 64 and then save this as a blue highlight. Okay. And then let me add that texture tools. Okay. Let's see. Assets, blue highlight. Let's save that blue highlight. DDS. Where is it? Where is it? Where is it? DDS. Okay. And let's load it into our engineer. Blue highlight .dds. Isn't that the file name? Yeah. And let's set our builder system here. Texture. Is it 4 of them? Let's see. So not this one, but 1, 2, 3, 4, 5. So yeah, it would be 4 because it's 0 offsetted, or rather starts at 0. Okay. So now we actually have a blue thingy. Yeah, I definitely need to edit the model. But anyway, um, we have our building stuff here, which is pretty great. Let's see, do we need any adjustments? No, I don't think so. No, I don't think so. So, did I do a model? Let's see. Chest tile blend. Okay, so let's select okay, so and let's do something like scale 0. And then this is let's see, definitely constrained. Okay, and this is going to be also, it's a bit off set, I see. Okay. And then export this. Tile, I think. Right. Let's save that and see what happens. Tile material, don't do that. Oh, let me see in Blender. Open that again. Did I export? Triangulate faces, right materials, don't. Yeah, that's fine. Okay, let's just redo it. There we go. Okay. Yeah, the weird things at the angle here. Maybe it's only supposed to be. Maybe it's supposed to be even thinner. Yeah, then we don't get those weird weird thingies. It's really thin now. Yeah, that's better. Okay. So I think that's it for today. Hopefully you found this helpful or inspirational or entertaining or something like that. Yeah, I definitely found it interesting to build out this part of the system. Let's see. So we did the hologram thingy. So now we have some build logic and containers to do. And I guess that's it. At least for now in the build system. Yeah. So if you found this helpful, entertaining, inspirational, or useful in some way, feel free to check out the description in terms of how to support the channel. Otherwise, I would love it if you would like or subscribe or leave a comment. Anyway, hopefully I'll be seeing you around, either here on the stream or maybe on the Discord server. Please take care, everyone, and keep on trucking. Bye bye.